In this set of class notes, this is going to be a lot like Standard 6, where I said that you need to be really careful to every time before watching the video of how to do one of these problems, you really need to try it yourself first, right? That's essential. So while I'm not going to stop every time and remind you to do so, make sure that before I start each example, you pause it and you do it yourself first. That's really key to this. It's not good enough just to kind of watch it being done and copying it. You need to really start to get a handle on it. Now, it's okay if you maybe get it wrong at first, especially on these first few. That's okay, but I really want you to try it. All right, so let's take a look at example number 1. So we're being asked to solve the tangent of theta equals -1. So what we need to think about first is this one of the special values on the unit circle? And when it comes to tangent, we really need to be watching out for 1s and square roots of 3. So when we see -1, remember what that's telling me is that the sine over the cosine is -1. So that means the sine and cosine are basically opposites of each other, right? So that's going to happen right here at -pi/4. All right, so I can say that theta is equal to -pi/4. Okay, but then let's think about where else on the unit circle could that happen? Well, directly across, the sine and the cosine are opposites as well over here at 3pi/4. So of course, if you go half the circle, that's a distance of pi. So remember our rule for tangent, you might remember this from the video notes, is that once you find one value, you find all the others by adding multiples of pi. Okay, and so k just stands for any integer, right? -3, -2, -1, 0, 1, 2, 3, and so on. All right, now it asks for all solutions between 0 and 2 pi. So what I want to do is take this, -pi/4. That's not between 0 and 2 pi, so let's see what happens when I add pi to that. And of course, getting a common denominator, well, that gets me that 3pi/4 that we already talked about. All right, but what happens if I add 2 pi's, right? So let k equal 2. Then I'm taking -pi/4 plus 8pi/4, which is 7pi/4, which is almost 2 pi, but not quite. So our answer to this specific question is 3pi/4 and 7pi/4. Now, notice what I did though. I started this problem, even though they only wanted answers in here, I went ahead and I wrote out the form of the infinitely many solutions. I wrote that out because then it helped me to produce the values that happened to be in the interval that was requested of me. All right, so now let's look at example 2. So we want to find all solutions between 0 and 2 pi for the sine of 2x equals the square root of 3/2. All right, so let's think about our unit circle over here on the side. Square root of 3/2 is certainly special value. So the sine is the y value, so that's going to be, when we're up here, right? That's definitely going to give us a sine value of √3/2. So on the one hand, what I'm going to do is I'm going to say the sine equals √3/2 when the angle, right, or the argument inside the sine is pi/3. So what I'm going to do is I'm going to write 2x plus 2x equals, pi/3 plus, now I know that anytime I add multiples of 2 pi, I end up in the same spot on the unit circle. So I'm going to go ahead and put plus 2k pi, standing for multiples of 2 pi. All right, my 2x equals that. But the other thing we learned in the video notes was that if pi over 3 is a solution, and we understand that sine is the y value on the unit circle, then where else on the unit circle would I have the same y value? Well, directly across here, right? And just from our knowledge of the unit circle, directly across from pi over 3 is 2 pi over 3. So what I can also do is say 2x equals 2 pi over 3 plus 2k pi. And remember what the rule is. If you find one solution and you're solving a sine trig equation, pi minus that first solution is always another solution. So we could have approached it this way by just saying pi minus your first solution, or by looking at the circle and surmising where the other place your sine is going to be root 3 over 2 happens to be. But here's the thing, this is so important. I put in the plus 2k pi in both of these before I ever even think about trying to get x by itself. All right, so now, of course, you need to get x by itself, but I'm doing it after that. And the reason that that's so important, you can see here. I'll multiply by a half on the left to get x by itself. But now you can see why I needed to put that 2k pi in, because as I distribute, so 1/2 times pi over 3 is pi over 6. As I distribute, that 1/2 multiplies by that, and I get plus k pi. And then the same thing here, 1/2 times 2x equals 1/2 times 2 pi over 3 plus 2k pi, which is x equals, the 2's cancel out, so that's just pi over 3 plus k pi. And then what I'm going to do is continue to add k pi until I get everything that's between 0 and 2 pi. So of course, pi over 6 is one of them. Pi over 3 is another one. All right. But then I'm going to go ahead and plug in 1 for k. So if I take pi over 6 plus pi, then that's of course going to give me 7 pi over 6. And then if I take pi over 3 plus k pi, that one's definitely going to give me 5, sorry, not, I didn't mean to say k pi, excuse me, plus pi. That's going to give me, not 5, wow, I'm having trouble with my arithmetic today, right? This is 3 pi over 3, so that's going to give me 4 pi over 3. And then what I can see here is that adding another pi to either one of these would put me over 2 pi, so I can definitely stop right here. So these are my 4 solutions between 0 and 2 pi. But I can't emphasize enough, I put the plus 2k pi up there as the very first thing I did before I ever tried to get x by itself. All right, now sometimes the trig function that we're dealing with may not be completely isolated. So I've got this 5 out in front of the cosine. And so what I know is that in order to make sense out of this, to be able to say when is my cosine equal to the right side, I need to have all this other stuff go away. right? So I'll start by multiplying by 1/5 on both sides. And one of the nice things that happens here is that I, of course, get the cosine by itself, but then also I went from something that didn't look like a special value to all of a sudden now I can see that it is, right? The cosine of pi times theta equals -1/2. And then I can go back and I can think about the unit circle. And I can ask myself, when will the cosine be -1/2? Well, that would be over here, right? So where is this? That to me looks like it's at 2 pi over 3, right? And so then that would be at 4 pi over 3. So I can say pi times theta is equal to 2 pi over 3 plus multiples of 2 pi, so 2k pi. But I can also say pi times theta equals 4 pi over 3 plus multiples of 2 pi. Now, again, what's our rule for cosine? Okay, for cosine, our rule for if we find one, the other one, I just looked at the unit circle to figure out, but remember, you can always find your second one by taking 2 pi minus the first one. And that, of course, gives you 4 pi over 3. Or you could say negative 2 pi over 3, right? The negative of the first one. But notice negative 2 pi over 3 would be exactly this, right? Going clockwise 2 pi over 3. So either way is fine. So if you'd put negative 2 pi over 3 here, that would have been perfectly acceptable. All right, but now we've got to go ahead and get the theta all by itself. So I'm going to take both sides of this equation and multiply by 1 over pi. And again, I put 2k pi in there before I ever thought about getting theta by itself. So I'm going to multiply by 1 over pi here. And then I distribute it through, and I can see that theta is equal to, well, the pi's would cancel, 2 pi over pi times 3 plus 2k pi over pi. So that's just 2/3 plus 2k, right? So it's the number 2/3 plus multiples of 2. And then we can do the same thing to our other version here. Multiply by 1 over pi on both sides. So we get theta is 4/3 plus 2k. So putting these two statements together gives us all solutions. And notice the difference between the instructions here and on the previous problem, right? This asks for all solutions. So when you give your final answer here, you better have a k involved, right? Where k can be any integer, as opposed to on the previous page where we gave a list of numbers because they were just asking for things between 0 and 2 pi. So you got to pay attention to those different types of instruction. All right, so we can now take a look at example number 4. All right, so kind of similar to our last one in that we're starting off with this number that we're multiplying the cosine by. All right, so we can of course divide by 3 on both sides. So I have the cosine of pi over 2x equals -2/3. Now at this point, -2/3 is not a special value at all. So now we have to take a little bit different strategy. I think it's still a good idea to draw a circle. Just understand that this is not a special value on the unit circle. So we're not going to expect to find that. But you can still mark where about negative 2/3 is, right? So think to yourself, cosine is the x value on the unit circle. So when is the x negative 2/3? That's about there. So that puts me there and there. Now I don't know what these numbers are yet, okay? But that gives me a picture of what's happening. All right, so how are we going to do this? Okay, well, if you have a function, right, of something equals a number, if you apply the inverse to both sides, then that's going to get the pi over 2x by itself, right? So we'll say this, pi over 2x equals the cosine inverse of negative 2/3. And of course, just like always, plus 2k pi. Now, I think it's a useful thing to go and understand the cosine inverse of negative 2/3. Which one of those dots is it? Remember that the cosine inverse always spits out values between 0 and pi. So I know that this is my cosine inverse of negative 2/3. Okay, so if that's the cosine inverse of negative 2/3, what's this? Okay, well, we know that if that's the cosine inverse of negative 2/3, that same distance in this direction is going to give me that as well. So you can do this either way. You can either say it's 2 pi minus the cosine inverse of negative 2/3, or if you'd rather, you could just say it's negative cosine inverse negative 2/3. It doesn't really matter. But what I would say is that they're asking for the first two positive solutions. So in light of that, I'm going to understand that this is going to be negative, this is going to be positive, so I think I'm going to use this one. But you could still end up the right answer regardless of which one you chose. So this will be pi over 2x is equal to 2 pi minus the cosine inverse of negative 2/3 plus 2k pi. Fix that there. All right, and we know in both cases we've got to multiply by 2 over pi to get x all by itself. So the exact form of my answer here, after all that nice cancellation happens, is 2 cosine inverse of negative 2/3 divided by pi plus, okay, we're going to have 4k pi over pi. And then over here, x is equal to 4 pi over pi when I distribute this to that. And then minus 2 cosine inverse of negative 2/3 over pi. And then plus 4k pi over pi. And then some nice canceling can occur, right? So we can have these pi's going away here, here, and here. Now, even though they're asking just for the first two positive solutions, I want to carefully kind of finish the job of getting the general solution correct. That gives me confidence that I'll have my approximate answers correct as well. Okay, so there's my general form of my solution. All right, but then it's asking me for the first two positives. Okay, of course, it's in this case, it's just going to be this, which is 1.46. And it's also going to give me this, which is 2.54. So those are my first two positive solutions. In this set of problems, we're going to do two different things. We're going to find all solutions. So meaning like I want to give answers like, you know, pi over 3 plus 2k pi, right? So I want to just encompass all solutions within my statement. And then part B, then I want to find all solutions that are between 0 and 2 pi. All right, so let's start with this one here. So we want the cosine of theta over 2 to equal 1. All right, so we can think about on that unit circle, when is the cosine of theta equal to 1? Well, the place that that's going to happen, right, and the only place that'll happen is here at theta equals 0, right? So theta over 2 would equal 0 plus 2k pi. Okay, so that's the only place on the unit circle that that will happen. Now, of course, we can drop that 0, so this can be, this is part A, by the way, theta over 2 equals 2k pi. And then to get theta by itself, we can, of course, multiply by 2 on both sides. So my answer in part A is just to say theta is equal to 4k pi. All right, but then part B asks to give all solutions on that interval. Well, we kind of already answered that. We said 0 is the only place on the unit circle that that's going to happen, or 2 pi, or 4 pi, or negative 2 pi, right? So just multiples of, well, and then, excuse me, when I get down here, it's multiples of 4 pi, not just 2 pi. So definitely 0, but if I let k be 1, then that's 4 pi, and that's bigger than this, right? And I can't go negative either, so my only answer here is 0. All right, now let's take a look at this one, right? So we want the sine of 4 theta to equal 0. So that means 4 theta is equal to what? Here's our unit circle. Well, here there's 2 places, right? So I can say that 4 theta is equal to 0 and pi, plus 2k pi in both cases. But hey, you know what? If they're spaced out like this, instead of giving 2 different solutions, would you agree that I should just be able to say 0 plus pi plus another pi plus another pi? So in other words, I can just say 0 plus k pi, or just k pi, right? So in other words, sine is going to be 0 every single multiple of pi. And then I can divide by 4. So theta equals k pi over 4. But then part B asks me to list all the solutions between 0 and 2 pi. So I can just start plugging k values in. So 0, k equals 1 is pi over 4. K equals 2 is 2 pi over 4, which is pi over 2. K equals 3 would be 3 pi over 4. K equals 4 would be 4 pi over 4, so pi. So this one has a lot of values we got to plug in to get all of our solutions between 0 and 2 pi. 6 pi over 4 simplifies to 3 pi over 2. And then lastly here, 7 pi over 4 happens when k equals 7. And then of course, if I went to k equals 8, then that would give me 2 pi, and we're not including 2 pi. So we have all 8 of these solutions between 0 and 2 pi. All right, so now taking a look at these two here. All right, let's look at the tangent first. So we've got, first of all, we want that tangent to be by itself, right? So we'll divide both sides by the square root of 3. So the tangent of 3 theta is equal to -1 over the square root of 3. All right, now I want to think about where this happens. And so remember, the key when we're talking about tangent is to say, can I make the top and bottom look like special values of sine and cosine? So that would be divide the top by 2 and the bottom by 2. So we can say, when is the tangent, or when is the sine a half and the cosine square root of 3 over 2, but they're opposites, right? One's positive, one's negative. Well, we can say that that's definitely going to happen over here in quadrant 2, right here, right? The sine would be a half, the cosine would be -√3 over 2, so that's 5 pi over 6. But then it would also happen right over here as well, a distance of pi away. And so remember, with tangent, you're always able to just write a single statement, 3 theta equals 5 pi over 6 plus k pi, right? We don't have to write two distinct statements when it comes to tangent. And I can multiply by a third on both sides. So this will be theta is equal to 5 pi over 18 plus k pi over 3. All right. So that's our answer to part A, right? But what about part B? This is where we got to list out all the ones between 0 and 2 pi. So we can definitely start off with 5 pi over 18 when you let k be 0. How about when you let k be 1? Well, then you're doing 5 pi over 18 plus, if k is 1, you're doing pi over 3. Okay, but that's going to be 6 pi over 18, so that's 11 pi over 18. And then we try the next one, 2 pi over 3. So that's going to be 12 pi over 18 plus the 5 pi over 18, which is 17 pi over 18. And then 5 pi over 18 plus 3 pi over 3, right? So we got 18 plus 5 is 23 pi over 18, and we're still not there. This is still just barely above pi, so we got to keep going. So how about 5 pi over 18 plus 4 pi over 3? The common denominator there would give me 5 plus 24 pi over 18, so that's going to be 29 pi over 18. And understand what we're kind of looking for, right? As long as we're under 36 pi over 18, that's under 2 pi, so we got to keep going. 5 pi over 18 plus 5 pi over 3. So that's going to end up giving me 35 pi over 18. So just under what we're shooting for. So looks like we have 6 solutions that fall between 0 and 2 pi. All right, so one more example here. We have we can divide by 2. So we have the sine of 3 theta is -1/2, but that's definitely a special value. So on that unit circle, the sine's going to be -1/2 down here, right? So it certainly looks like what we have is 7 pi over 6 and 11 pi over 6. So we get two separate statements here. 3 theta equals 7 pi over 6 plus 2k pi. 3 theta equals 11 pi over 6 plus 2k pi. Right, and we can of course get theta by itself by multiplying by a third on both sides. All right, so we have theta equals 7 pi over 18 plus 2k pi over 3, or theta equals 11 pi over 18 plus 2k pi over 3. And then we play the same sort of game we did in the last one for part B, right? So of course we have 7 pi over 18 and 11 pi over 18 when k is 0, all right? But then we can start adding more, right? So this can be 7 pi over 18 plus 2 pi over 3. So that's going to give me 23 pi over 18. This one would be 11 pi over 18, so I'm alternating over to that solution, plus 2 pi over 3, like, right? So I'm letting k be 1 here. And so that's going to give me, let's see here. Oh, I think I might have, oh, excuse me, that's not 23 pi over 18. Sorry, I was a little too much on autopilot there. This one, of course, you're going to make this 12, so 12 plus 7 is 19 pi over 18, and this second one is 23 pi over 18. And then 7 pi over 18 plus 4 pi over 3, where we're letting k be 2. So that one's going to give me 31 pi over 18. And then lastly, this one's going to get us there, 11 pi over 18 plus 4 pi over 3 is going to give me 35 pi over 18. So 6 different solutions for this one as well, between 0 and 2 pi. So to wrap this up, I want to do a couple more where we don't necessarily have special values that we're looking at. And specifically, we're going to give answers rounded to the nearest hundredth that are between 0 and 2 pi. All right, so for this first one, we know, and we can still sketch on the unit circle even though 0.4 is not a special value. The sign should be 0.4, so that puts it right about there. So we know we're going to have a solution here and a solution there. But since it's not special, the only way to get at it is to say 2x must equal the inverse sine of 0.4. And then, of course, plus 2k pi. All right, so that's the inverse sine. And we know it's this one because it's between negative pi over 2 and pi over 2, which is what the inverse sine is always going to spit out at us. Now for our other solution, right, the other part of our solution, we need to figure out this. Okay, but you can see what it should be, right? And or maybe you memorize this, but if you know that this is the sine inverse of 0.4, then all the way here, so I could go pi and then backtrack that amount to get to my other one. So the solution there is pi minus the sine inverse of 0.4. And then, of course, plus 2k pi. And then in both cases, we can divide by 2 on both sides. So I end up with x equals the sine inverse of 0.4 over 2 plus k pi. And then x equals pi minus the sine inverse of 0.4 all over 2 plus k pi. Now this, right, if I take k to be 0, this right here gives me 0.21. And then if I take k to be 0 over here, that one gives me 0 or 1.37. Now if I let k be 1, so if I take sine inverse of 0.4 over 2 plus pi, then that's going to give me 3.35. And then if I take pi minus the sine inverse 0.4 over 2 plus pi, that's going to give me 4.51. Now if I tried one more, I know it's not going to work because I'd be taking 0.21 plus 2 pi, and that's obviously going to take me outside of 2 pi. But you know, as you're doing these lists, maybe a good thing is just to always remember, right, when you have approximate solutions, that 2 pi is 6.28, right? So as long as you're under that, you're in that interval 0 to 2 pi. If you get over that, then you've obviously gone outside and can stop. All right, last example here, doing the same thing though. Want all the solutions between 0 and 2 pi. So again, negative 1/3, not a special value on the unit circle. So we're going to have to rely on the inverse cosine to help us out here. So negative 1/3 in the x is right about there. So I've got a solution here and a solution there. So this is going to be 3x must equal the inverse cosine of negative 1/3 plus 2k pi. But then we also know if we have one solution, right, and this is definitely that because it's between 0 and pi, which is the range of values that the inverse cosine spits out. This one can be found by taking 2 pi minus that. So 2 pi minus the cosine inverse negative 1/3 plus 2k pi. And so then I can definitely divide by 3 on both sides. I'm dividing everything by 3. So this is x equals the cosine inverse of negative 1/3 all over 3 plus 2k pi over 3. And x equals, and like I said, everything is being divided by 3, right? So I'm going to take both of those divided by 3 plus 2k pi over 3. All right, and I can do the same thing I did in the last one, right? I'm going to plug this in to get 0.64. I'm going to plug this in and find that it's 1.46. And then I need to start plugging in values for k. So when I plug 1 in for k, 0.64 plus 2 pi over 3, that's going to give me about 2.73. Then if I take this one, 1.46, plus 2 pi over 3. That gets me about 3.55. Now notice 3.55 is just a little bit larger than pi, so I'm guessing I need to keep going here. So 0.64, plugging in a 2 for k would give me plus 4 pi over 3. And that gives me 4.83. And then my other one, 1.46 plus 4 pi over 3. That one gives me 5.65. And that's getting pretty close to 6.28. And definitely notice if I added another value here, it would be 6 pi over 3, which is 2 pi. So that is definitely going to take me over the top.